Welcome. Today we're going to use Newton's laws to solve an old and very interesting riddle. And the riddle goes as follows. Imagine a delivery van that is filled with birds which are sitting on its floor. Will this van be the same weight, heavier or lighter, with the same birds flying around inside? Interesting, isn't it? We're going to apply Newton's laws to the birds in the van, the imaginary birds in the van, in order to come up with a solution. And we have a representation in front of us on the board of those two scenarios. Firstly, we have the birds here represented by just one bird, which will suffice for our analysis, sitting on the floor of the van. And in the second diagram, we represent the birds flying around inside the van. And the question is, in which of these two cases will the van be heavier? Of course, if we're considering the weight of the van, really what we're looking at is we're looking at the downward force that the van exerts on whatever surface it is on. And that downward force, in this case, can be represented by these two arrows, and in this case, represented by those two arrows. You can imagine the van on a scale, if you like. And the question is, would that scale have a higher reading in this first case with the birds on the floor, or in this second case with the birds flying around? Would that reading be higher, lower, or the same? It will benefit us at this stage to have a quick recap of Newton's laws of motion. And there are three laws, as any good physics student will remember. Newton's first law deals with what happens when a body is not subject to a resultant force. And it states that an object will remain at rest or continue to travel at constant velocity unless acted on by a resultant force. So Newton's first law essentially tells us that a body will continue to do whatever it was doing unless there's a resultant force which causes it to do something different. Newton's second law deals with what happens when there is a resultant force acting on a body. And it can be stated as follows. The resultant force acting on a body is equal to the body's rate of change of linear momentum. Another way of looking at Newton's second law is to say that when a body is acted on by a resultant force, it will accelerate with an acceleration that is proportional to the resultant force. So Newton's second law can be summed up in our common equation F is equal to ma. The resultant force acting on a body is equal to the product of the body's mass and its acceleration. And the resultant force and the acceleration are always in the same direction. So these two laws of motion can be bunched together because they deal with what happens to bodies in the case where you've got a resultant force acting on the body and in the case where you don't have a resultant force acting on the body. Newton's third law, however, is slightly different. It deals with what are called action-reaction pairs. And action-reaction pairs are pairs of forces which act on different bodies. Newton's third law can be stated as follows. For every action force, there is an equal and opposite reaction force. Now let us apply Newton's laws to both of these scenarios. Firstly, with the birds sitting or standing on the floor of the van. The birds will have a weight, and that weight acts downwards. In order for the birds to be in equilibrium, there must be a force which balances this weight which acts upwards. And in this case, that force is the force that the floor of the van exerts on the birds. And I'm going to call that R, a reaction force. And note that the weight of the birds and the reaction force, both of those forces act on the birds. So they are not a Newton action-reaction pair. But we use this diagram to explain why the birds remain in equilibrium. That is, they do not accelerate. Coming back to applying Newton's third law and finding the action-reaction pairs which are at play, in this diagram, we see that the birds exert a force on the floor of the van. And this force is in fact equal to the weight of the birds. And I'm going to call it W because it's equal to W. The floor of the van exerts an equal force on the birds, which I'm going to call R. Those two are an action-reaction pair. And this force, which I have labeled as W, which is the force that the birds exert on the floor of the van, that force contributes towards the total weight of the van. So the van in this scenario here will have a certain weight, and that weight is contributed to by this force, which is the force that the birds exert on the floor of the van. Now let's have a look at this scenario where the birds are in the air. And again, we've represented the birds by one bird which is in the air. We know that the birds will have a weight. And this weight is the same as it was in the first scenario. It is represented by the arrow labeled W. For that bird to remain in the air, for it to be in equilibrium, there must be a force which is keeping the bird up. And the way that this force comes about is as the bird flaps its wings, the wings push air downwards. That air which is pushed downwards, according to Newton's third law, will exert an equal and oppositely directed force upwards on the bird. And this force is the force that keeps the birds in the air. So we can represent that force as an arrow directed upwards. And we'll call it F. So now we've explained how that bird remains in the air. But what happens with this force which comes from the air and keeps the bird up? That force has its origins in the fact that the bird's wings move air downwards. Eventually, this air is going to collide with the floor of the van. As it collides with the floor of the van, that air will experience a change in momentum. That change in momentum, according to Newton's second law, will result in a force which is exerted on the floor of the van. That force, which in total will be equal to F but oppositely directed, will contribute towards the total weight of the van. And in fact, this force which acts downwards due to the air on the floor of the van will equal to the weight of the birds. And so when we look at the two scenarios, the birds on the floor and the birds in the air, the weight of the van remains the same. And this is because in the first instance, the force that the birds exert on the floor of the van is equal to their weight, and that is a contact force as the birds sit or stand on the floor. And in the second case, in order for the birds to stay in the air, they must exert a force on the air, which in turn exerts a force on the birds, and this air will eventually exert a force on the floor of the van. That force which the air exerts on the floor of the van will be equal to the weight of the birds. So in both cases, the birds contribute a downward force on the van which is equal to their weight. So the weight of the van in total is the same in both cases. If you found this riddle and its solution of interest, if you're a student in physics and you're interested in increasing your ability or achieving mastery, Learning Space can certainly help you. Learning Space offers topic-based courses which are rigorous in nature and help students reach their aspirations in sciences and other academic subjects. Like us on Facebook, visit our webpage and find out how we work.